Today, I'm very excited because I'm starting a new series and it's about agent architectures, design patterns too. And we will start with a new episode. It's called It Worked in the Demo, Then It Met Tuesday. Agent products die for systems reasons, not model quality, and the bigger model won't save them. So today's morning is Monday. You have the board demo. An invoice agent reads PDF, it extracts the amount, it matches it to a PO, and then it posts it to an ERP. You have 30 seconds, 0 clicks, it's amazing, everyone is clapping, everyone is happy, you're getting a promotion, amazing day. Then Tuesday, production hits. Exact 4 steps, but now they meet real life. The issue is that you will have failures. First of all, for example, no PO number, no purchase order number. Then, so what does the agent here do? It guesses a purchase number, which would be catastrophic, of course. And another issue could be that you have the vendor existing twice in your master data. So it pays the vendor a duplicate. For example, let's say you would have this issue would happen if you have the same vendor, but with two different data, for example, bank details. So it would pay the first bank details and the second. That's another issue. One more issue is that, for example, the financial department raised the approval threshold last week and the agent's still running on the old one. So it posts something that should have helped. This is the third issue that could have happened. Many issues could happen in production, of course. Then someone asks the only question that matters. Can we just stop it? No one is answering, and that's an issue. That company is preparing itself for a catastrophe because this is a very documented issue. There were real AP exception rates and a coding agent that deleted the production database during a freeze in July 2025. So this was in Air Canada, and the deletion came from a chatbot's advice. And Air Canada was made to pay back all of the money that all of the losses that they incurred in that day. So here is the question that our channel truly exists to answer. The agent died on Tuesday. What killed it? Because it was not the model. Frontier model would still have the same problems, would make the same mistakes if you give it the same situation. It wouldn't be able to correct itself or somehow find the real PO number. So there was actually a prediction from Gartner, and it says that over 40% of agentic AI projects will be cancelled by the end of 2027. So this isn't a hot take. They actually reaffirmed it in their first standalone agentic AI hype cycle in April 2026. And most people would stop at the number. But what I think is really interesting is the causes. So these are the three named causes. First of all, escalating costs. That one is understood. After that, unclear business value. And third is inadequate risk controls. So let's read the list again because this is something I already said. The model, no one is naming the model here or says the model is the reason something didn't work. A better model builds none of these. It doesn't write your own business case. It doesn't cap a runway cost. It doesn't install a single control. So the causes of death are systems causes and management causes. The killer is never the model. That is the thesis of this entire channel. And everything else, this episode just piles evidence on it. So you have this picture, which is older than agents. It's a very interesting picture because I need to explain it. So what this picture is, this is a real agent system drawn roughly to scale. So you have data validation, you have exception handling, you have identity and authorization, you have cost control of switch, audit trail, policy configuration, monitoring. All of this is not LLMs or AI, that's engineering. Now let's try to find the model in it, and here is the model, all inside of all of these elements. So this picture actually comes from 2015. It was Google engineers who published exactly this diagram. It was just a small, tiny box labeled machine learning, and it's basically drowning in everything else. Their caption said only a small fraction of a real machine learning system is the machine learning code. So today we are 11 years later, and I still agree 100% with this stance. This picture doesn't change. You could just, back then they had ML here, and today you could just put LLM instead of it. So there is something that's very important, is that 2080. What is meant by 2080? 2080 is that 20% of the success of your project will come from the LLM, and 80% will come from the engineering all around it. This is a very important point that you need to understand very deeply. So this is not a measurement. Nobody measured 2080, but the small box survived a decade and a whole technology swap. So you need to understand this I think this box will survive for the next 100 years, in my opinion. So let's look here. This is your demo on Monday. You're happy, you have your invoice, you're reading here, you extract the invoice, then you look up the data in your database. Everything is clean, everyone is applauding, you're happy, you get a promotion, life is good. Then you deploy it to production and problems start to happen. So this is the lines of codes. This is like pseudocode. This is not real code, but basically all of the things in red here, everything in red is all of the things you'd have to add when you're deploying. So let's say you have an invoice without a PO number, and that becomes like a validation branch and an exception queue. So because here you can't let your LLM guess the number of your PO, of course, that would be catastrophic. So that's for one. The duplicate vendor here. So it becomes also a resolution step against master data. So it's all of this is deterministic code. You can see here too, you have changed last week, you have no double pay, you're checking for no double pay, you're many things. So for example, you're also posting money gets an idempotency key, so a retry can't pay twice, as you can see here. Like all of these things you would need to do, because this is what people actually do in real life. You're actually doing these checks by hand. So your agents need to do deterministic stuff, deterministic checks that you need to do, of course. So all of these also need to be audited. So all of these actions, you need to put them in an audit line so that basically later on you can deliver them. You can prove that everything went well. And the whole thing is wrapped in a kill switch that's actually checked. If you look at what we added here, we have 8 blocks. We had here, 5 blocks in the original one, and we had more plus 8 blocks of just deterministic code. So that's the main lesson I wanted you to understand, is that this is the lesson of the 2080. The failures, most of the time, are in the 80, are in the data around, are in your data engineering around your model. It's not really your model. You can improve your model and still have the same problems. It would still send you back trash. Actually, I know people who, because of costs, still to this day use older models in production, of course. They don't upgrade, and everything is working well, everything is amazing, and because that 80% around your model are actually of good quality. So there was actually a study that described all of this. There was a large scale one, and you don't need to remember anything here, you just need to understand what's happening. So in this study, you had 306 practitioners, 20 deep case studies, 26 domains. All of these agents were deliberately constrained. So what did the work in agents actually look like? You have 80% of them, of the case studies, about 16 out of 20, that ran structured for workflows, not really open-ended taxonomy. We will talk about structured workflows next episode. 68% of the deployed agents run at most 10 steps before a human steps in. So this is the second one. 70% just prompt off-the-shelf models. So no fine-tuning, nothing added. They never touch weights. and 74% rely on human evaluation as the primary check. So this will be the subject, the 80% will be the subject, so this will be the subject of next episode. We'll talk about that more deeply, about how to choose workflows, when to use LLMs. And one thing about this study, in the author's own words, teams deliberately constrain autonomy for production stability. That's the opposite of the sci-fi pitch. Autonomy is a budget that gets spent carefully, not maximized. One caveat, this study surveys teams that shipped, so there is a huge survivorship bias here. So it's actually describing what actually survived, not really what are your odds of success here. Your odds of success currently they are about of 25%, which 25% of projects actually succeed, which is not an amazing figure to be honest. Hopefully through the series we can improve it. So one thing you need to know is that the other side of the ledger is just as true. In LangChain 2025 survey, 57% of respondents already had agents in production. In PwC's survey, you had 79% of companies that said, of US executives, that agents were being adopted. So both facts hold at the same time. Agents are shipping and delivering value, and over 40% of projects will die. And which is a lot. 40% is a lot, of course. So what sorts one group from the other? The same models are available to everyone. The difference is, as always, the 80%, the data engineering around your models, the data mining, the data quality, the shipping, the deployment, all of these things you need to be very, very good at. One more number I wanted to tell you to be careful of. It says like 95% of AI fails. It's not real number. It's more non-peer reviewed preliminary study. I would say generally these are pilots. They're projects people were testing. They are not really advanced. So if there is a credible number that is peer reviewed, where the data is verified and everything, then I would put it in this channel. But 95% of AI fades is a lie. So you have 4 fences here, so you know exactly what you're watching. This is not really a hype takedown. I'm not saying models don't matter or just prompt better or framework, or it's not even a framework tutorial here. What I'm trying to tell you is that agents are real and the production numbers prove it. It's not trying to hype AI down. Anyone who thinks that AI has no future or Gen AI will not be the future, or at least is not a huge revolution on the technology side, is frankly a fool. And the idea of this series is to build on concepts, to present you where the problems will happen, how would you approach this as an engineer, how you would build on critical thinking. So the series in one sentence, we build the vocabulary and the architecture judgment floor by floor, and we carry this one accounts payable agent, AP stands for accounts payable, all the way up. This is the first episode, and step by step I will be talking about architecture. Next episode starts with the most abused word in this field. 2 teams both say they built on an invoice agent. One wrote 200 lines of if-then that call a model at each step. The code is driving. The other lets the model decide what happens next. The model is driving. Same word, opposite systems, and there is exactly one question that separates them. Who's driving? See you in episode 2. One thing before I leave, if you like the content, please like and subscribe, and follow me on LinkedIn. I do have some interesting thought there.